The spawn test, as mentioned earlier, manifests part of the functionality of the collision spawn test. The difference with the spawn test is that no collision is required to actually cause the particles to be spawned. Indeed, the spawning can be continuous from the moment the birthing particle enters the event. As with the collision spawn test, you do have to take care to pass any spawn particles out to a new event, and it's often a good idea to cull these new particles after a certain period, especially if your spawn test is creating large numbers of spawn particles per integration step. If you do not pass the spawn particles out to a new event, then you should be prepared for the resulting explosion that will result in your particle count. With this test, rather than me going through every parameter in a slavish manner, I will simply cover its unique functionality in comparison with the spawn test covered earlier. So let's have a look at the parameters. We have a spawn here, and we also have a spawn here. Let's actually have a look at the first one here, and we'll just run through the parameters in this that we actually want to check through. The first group that we have here is the spawn rate and amount group, and this group defines the frequency with which particles should be spawned from the test. There are three main options. You can see you have once, and with this first option each particle will spawn once upon entering the event. The amount of particles and their characteristics are defined in the rest of the rollout. The one other parameter that is only associated with this option is delete parent, which you can see here. And this option only becomes active when once is the chosen frequency option. When active, this option will delete each particle after it's spawned. If it spawns just one particle, and this is set to inherit all of its parents' profile, you can use this setup to reset the particle's age, as long as the reset particle's age parameter is set below. The second option is per second, and with this option you can define a certain quantity of particles to emit per second. How this relates to individual frames will change, of course, based on which time system you're currently using, i.e. PAL, NTSC or film. With PAL you have 25 frames a second, with NTSC you have 30 frames a second, or near enough 30 frames, and for film you have 24. If you wanted to emit one particle per frame whilst using PAL, you would have to use a rate setting of 25. For 10 particles per frame you need a rate setting of 250. So as you can see, you have to bear in mind that this setting is actually per second rather than per frame. When this is active, this spinner here actually becomes active as well, as you can see, and in here you can actually enter the amount of particles to emit. The next option is by travel distance, and with this option your particles are spawned once every time the spawning particle travels the distance defined in the step size parameter below. This option is particularly useful when you want to emit a trail of particles. In this case, set a suitably low step value and set the spawn particles to inherit a very little or none of its parent speed. Beyond this point, the parameters follow pretty much the same format as that seen in the collision test. So for more reference on that, it's actually best to go back and look at the collision test operator. The only marked difference is that there are no parent and offspring flyouts in the speed group, as in this case they're simply not needed, as this isn't a collision test. Please have a look through our example file to get an idea of how the spawn test can be used in practice. As you can see, it has been used in two separate places to produce a particle trail and also an explosion of particles based on an age test. This is a relatively simple operator, but it's one of the most useful items in my toolkit, so I'd suggest you really become familiar with it and use it as necessary in whatever circumstance you come across. So before we skip on to the next chapter, let's quickly run through what this actual test does in this particular setup. You can see we have a source here which fires up particles. You can see that we have a gravity space warp and we have a drag space warp. So you can see both of these are used to make this particular simulation a little bit more realistic. Obviously the gravity will make our particles fall downwards, and drag will actually slow our particles down as they travel through space. So you can see we birth particles from frame 0 to 13, and we only birth 16 of them. We're using subframe sampling there. Then we set the position, which is based on the source here. We set a speed, which is along the icon arrow, and you can see that we've got some divergence to make the particles go off at a random angle. Then we spawn particles, and you can see I'm using the by travel distance value, and this means that we're going to spawn one set of particles every 0.3 world units as the particle actually travels through the scene. You can see that every time that this value is met, we offspring one particle, so that actually keeps it under control. If we want to emit more than one particle every time we travel this distance, you can actually change this value here. And this, as I said, works in exactly the same way as the collision spawn test. You have variation values and so on, and you can also animate them. You have control down here of the particle age. You can reset the particle age, and you can inherit the particle speed or set it in system units and so forth. Also, again, you can set the scale factor and variation. So you can see that we have a wire going from here to pass the particles out into a new event, where you can see I've got a force, which is actually not used in this particular case, so I'll just get rid of that. And you can see that this is actually used for the actual explosion. So what I'll do is I'll actually undo what I just did. There we are, and we'll actually just add this force in here. And I'll get rid of this one. There we go. So this is actually the particle trail which comes out, and when it reaches an age of 35 with a random value here of 16, plus and minus 16, the particle will be sent off to another event where you can see it spawns a lot more particles, but in this case it only does it once. It deletes the parent and it emits 110 particles. You can see that the speed of the particle is inherited, and we're using a lot of divergence here to actually send them off in different directions. Then we override that value and we just use a speed operator to use a speed of 101, and it's using a random 3D direction. We apply gravity to the particles, we apply drag to the particles, and we delete the particles after 18 frames plus or minus 14. So let's have a look at that, how that actually works out when we actually play it. There you go. The particles fly up into the air, and as you can see, this gravity that I've added here is actually much too strong at the moment. It's making our trail particles fall downwards, but they're actually falling very, very quickly. So I'll just go into this gravity here and we'll make it much, much weaker. Let's try 20%, and let's run through that simulation again. As you can see, they're still falling too quickly, so we'll just use a really tiny value. There we go. So now, as you can see, the particles start to fall in the trail after a certain amount of time. And you can see that after a random period, our particles go into the air and create a burst, a little bit like fireworks, really. In DVD 5 in this series, we'll actually look at producing fireworks in a little bit more detail. And in that DVD, I'll actually try and produce various types of fireworks. So I think that'll be useful for anybody producing any animations for the 4th of July, or for Guy Fawkes Night in the UK, or any other sort of celebration, you know, New Year worldwide. Okay, so that's it for the spawn test. Let's move on now to the speed test.